Hi, welcome to my channel once again today. In today's math tutorial, we want to find the sum of two difficult series. They are JEE Advanced Maths problems. But before we go on, if you are yet to subscribe to my channel, please click the subscribe button now and click on the notification bell so that you do not miss out on any of the updates coming out from this channel. Now let us find the sum of the series. Here is the first one. We want to find the sum of 1 times 2 times 3 plus 2 times 3 times 4 plus 3 times 4 times 5 that continues like that up to the nth term. Now, this is kind of a tricky one, but I will do it in such a way that you will appreciate it. So first, if you take a look at every term of this sequence, every term can actually be written as k times k plus 1 times k plus 2. Have you checked it? Did you find it to be true? Yes, it is true. Every term can be written in this form. That's like the general term for each term here. Now, k actually ranges from 1 to n, since we want to find the sum up to the nth term. This we are going to expand further. That gives us first k squared plus k. That's the product of k and k plus 1. And that multiplying k plus 2. Expanding this further gives us k cubed plus 2k squared plus k squared when k is distributed and plus 2k, which is eventually k cubed plus 3k squared plus 2k. Now we will let the sum of the series be Sn. What this simply means is that Sn is the sum of the series, and since we have made a representation here for the series using the general term for each term, we can write this as summation k is from 1 to n of k cubed plus 3k squared plus 2k. Then we are going to find this sum. Easy, isn't it? Now we are going to make use of very important properties of the summation notation. One of them is when we are looking for the sum, say a equals 1 to r of the constant m multiplying the variable x a. This is the same thing as the constant times the sum from 1 to r of the variable xa. The second one that will be much needed also is when we have the sum, the summation a equals to 1 to r of a sum, say xa plus ya. This is the same thing as the sum a equals to 1 to n of xa plus the sum a equals to 1 to r of ya. Applying this on the sum Sn above, we have Sn becoming the sum k equals to 1 from 1 to n of k cubed plus there is a constant 3 multiplying k squared, so that becomes 3 sum k equals to 1 to n of k squared plus 2, the constant multiplying k, summation k from 1 to n Okay. At this point, we'll be making use of important sums. For instance, the sum of cubes, x cubed, for instance, is n squared times n plus 1 squared over 4. The sum of squares, that is n times n plus 1 times 2n plus 1 over 6. And the sum of natural numbers, sum of x, is n times n plus 1 over 2. Applying this to the sum above, Sn is going to be n squared times n plus 1 squared over 4 plus 3 times the sum of the squares, n times n plus 1 times 2n plus 1 over 6 plus 2 times n plus 1 over 2. Now, looking at these three terms, we have a common factor of n times n plus 1 over 2 that we're going to factor out, leaving us with n times n plus 1 over 2 plus 2n plus 1 after reducing 3 over 3 plus 2. So the sum becomes n times n plus 1 over 2 times, in the parentheses, the rectangular one, we have an LCD of 2, where we have n times n plus 1 plus 2 times 2n plus 1 plus 4. We continue to simplify the rectangular bracket. So n times n plus 1 over 2 is going to be multiplying n squared plus n plus 4n plus 2 plus 4 over 2, becoming n times n plus 1 over 2 multiplying n squared plus 5n plus 6 over 2. Now, n squared plus 5n plus 6 factors as n plus 3 times n plus 2, so that this becomes n over n plus 1 over 2 times n plus 2 n plus 3 over 2, finally becoming n times n plus 1 times n plus 2 times n plus 3 over 4. That's the sum of the series up to the nth term. And this can be used to find the sum of any terms. For instance, let us use it to find the sum of the first 6 terms of the series. The sum of the first 6 terms means when n is 6. Therefore, x6 is going to be 6 times 6 plus 1 times 6 plus 2 times 6 plus 3 over 4. And that is 6 times 7 times 8 times 9 over 4. The sum of the first 6 terms is 756. In the second one, we have to find the sum of 2 times 5 plus 4 times 7 plus 6 times 9, and the order continues that way. Now, we can write it as 2 times 2 plus 3 plus 4 times 4 plus 3 plus 6 times 6 plus 3 and it goes on like that. Again, we write this as 2 times 1 times 2 times 1 plus 3, so as to get a pattern that we can write a general form for. Plus 2 times 2, which is 4, times, in the parentheses, 2 times 2 plus 3, plus 2 times 3 for 6, and in the parentheses, 2 times 3 plus 3. And the sum goes on. Now, generally, every term can just be written as 2k times 2k plus 3. I believe you get that. So once again, if we let Sn be the sum, then the sum is k from 1 to n, since we're looking for the sum up to the nth term of 2k times 2k plus 3. Then we are going to open up the parentheses. We distribute 2k into the bracket so that Sn becomes the sum from k equals to 1 to n of 4k squared plus 6k, which from what we did earlier on can be written as the sum from k equals to 1 to k equals to n of 4k squared plus the sum k from 1 to n of 6k. This can further be written as 4 times the summation of k from 1 to n of k squared plus 6 times the sum k from 1 to n of k. And applying the sum identity, we have Sn to the 4n times n plus 1 times 2n plus 1 over 6 plus 6 times n plus 1 over 2. Here we're going to factor out n times n plus 1, leaving us with, in the bracket, an LCD of 6. Then we have 4 times 2n plus 1 plus 18. That becomes n times n plus 1. Then in the parentheses, we have 8n plus 4 plus 18 over 6, which is n times n plus 1 times 8n plus 22 over 6, dividing the parentheses, the last one, by 2 all through. We have n times n plus 1 times 4n plus 11 over 3. This is the sum of the series. I believe you enjoyed the math tutorial today. Let us know in the comment section. Don't forget to like and share the video. And if you are yet to subscribe to this channel, please subscribe now. And don't forget to follow us from time to time, even as we make new videos. Thank you for watching this video, and bye.